I'm ready to be enlightened.
That's good. Perfect mindset.
Holy shit, it's an eye test.
A.
Come on!
Maybe I'll have everybody stand up around, huddle around me, I don't know.
Stop your complaining, don't you have an overhead detector? Binoculars are on the dash. Alright.
Good. Can't see it anyway, why not?
Did you see my email this morning about?
I just got home.
Do you think there was tables by chance?
I think if we bring this one table out there for the instructors, I think that'll be plenty.
You know, think the students will need writing surfaces?
I think it's gonna be mostly hands-on, but it may not be a bad idea.
Well, I mean, we have to rent them.
Well, actually,
Jeez, you got a lot of stuff on you.
You know what I've got?
We could switch it.
I've been working on it for weeks.
Actually, I got a mess too.
No, I like
Have a year.
I have fun too, so it's good.
No, I got
It wasn't as complete as I would like.
I'll throw a couple of business cards out here also, just so you guys have a way to contact me if you have any other questions, type of thing. A few more on the First of all, I guess I want to say thanks for everybody getting together on short notice to come up here and learn about the truck. My name's Troy from the Darley company. I was a mechanic there for about 5-6 years before I started building one of our first, well not our first of our newest generation of our compressed air foam systems. We had dabbled a little bit back in the 70s and 80s with compressed air foam. Worked with some of the vehicles that were part of the Texas Forest Firefighting Agency, and but back in '93 we put together one of our first systems, and kind of started traveling the country since then, doing demonstrations, teaching people about compressed air foam, and that's kind of my forte to this day. I got a mechanic background from building quite a few trucks for Darley, and then now come out and do training with new deliveries, get into some sales and some service issues, those types of things. So basically from end to end on the truck, any questions you guys have, I can either try to answer the question for you here today, or I can get you an answer, because I know all the various people at the organization that I need to talk to find out the correct answer to your question. So my whole goal here today is to make you guys as comfortable as possible with operating your new engine outside. So at any point, if I say something that doesn't make any sense, or if you got any questions, just stop me and we'll try to get any questions cleared up as quick as possible. My main focus, yes?
Everybody else here may know this, but I'm curious. We have about at least 6 guys who ought to be here,
Okay.
and they're not here. And I'm curious to know what was the reason for this short notice and like that.
Well, sir, I can tell you on our behalf, about a month ago, I started communicating with a few people through email saying that I was planning a mid-September trip out here. And it was based upon trying to figure out exactly what date our company's open house was going to be for our new building. And immediately after that, I was going to book tickets and come out here. And at that point, I had communicated with those gentlemen and tried to arrange for this, the last few days and for the next couple of days that I'd be in the neighborhood. And I guess it was just a matter of, we all weren't communicating often enough as to when I was coming out. But
Okay, well, the reason I'm asking is because, as I say, this is a Sunday afternoon. We could easily have had twice as many guys here.
okay, that's unfortunate. I don't know what more to say on it.
Well, it's not as if the truck just started Friday either. I mean, the truck's been in the works for a couple of years. So.
That's
Anyway.
correct. That's correct. And there was also, what I would have considered a pretty good amount of education given to a few at the factory to understand how to get the truck in operation also, short of getting into the detail of maintenance. But from an operational standpoint, you have one of the easiest CAF systems on the market to operate. So from an operational standpoint, we only have a couple of switches that need to be operated.
Okay.
So it's going to be a rather simplistic vehicle to operate. It's not much more difficult than a plain water pumper. There's just an additional switch to turn on an air compressor and an additional switch to turn on a foam proportioner. I mean, it's just a simple push of a button. So once we cover those step-by-step operational procedures, and do we have a copy of that step-by-step operation procedure that I handed out at the factory for what to do? But I'm sure hoping we can at least get, all the other personnel that aren't here, I'm hoping that at least the group here might know what their questions are. I'm sure we've had to have had some meetings and some times going around the truck where everybody has a pretty good feeling for what unknowns there are about the vehicle. I hope we can cure most of those within the next couple of days. And I will be available, all day tomorrow also for anyone that, has the day or has the ability to work tomorrow or tomorrow evening if need be.
And Troy, if I could just add for you guys, my name's Tom Schroeder. I work for Darley out of Littleton, Colorado. I'm with the pump division. I can help you work through any issues or concerns you have once he's not available anymore. And that's a real easy commute. It's about an hour away. If you're not familiar, it's just south of Denver.
So Tom can also
Happy to come
help
up
out
again
quite a bit.
and talk to the 6 that are not here.
Okay. I know this is kind of small print here, but I think we can work through this pretty easily. What I'd like to start to do through the training is at least explain how a basic plumbing schematic works, what components are used in a compressed air foam system, so that when you're actually standing at the pump panel and you're opening a lever, that you know exactly what's taking place inside the pump compartment. So when you pull a lever, you know what valve is moving, you know where the water and the foam are mixing in the line, and you know what flipping a toggle switch to turn on the air, where that takes place and how that works. And then I can also explain all the different various things that you can do with those different valves and switches. So I think what I first want to start out here is with the pump itself. This is just a basic piping schematic. It may look kind of complicated here on paper, but we just have the water pump, which is basically starting here. We have a variety of different types of outlets. We have a booster reel here. We have a couple of different cross-layer pre-connected swivel joint type lines where you're pre-connecting a hose bed. This is just showing an optional front spray bar or rear spray bar for a wildland type application. And this would just be showing like an onboard deck gun or monitor type of an outlet. And what I just start with is I explain that we start at the water pump. The water pump is a centrifugal pump. It's going to pump water out to all of its various outlets. Okay? It's going to supply water to all the various outlets. Any outlet that can provide water, now we're going to have water to that source. As soon as that pump is put into gear and it's starting to spin, it's going to provide water to all those various valves. What we have here also is a 3-inch straight line to the deck gun, and off this same manifold you'd also have a valve that would go to your water tank to keep your water tank full. And the reason I point all of this out is that if you don't turn the foam system on or the compressor system on, all of your outlets are plain water outlets at that point. Now once you decide if you want to start using foam, there's a line, a predetermined manifold line that comes off the main pump discharge head that's going to feed this manifold, and this is what's known as a basic foam manifold. There's going to be a paddle wheel in line here, which is basically just a free-flowing paddle. That's an electronic device that sends a signal up to your foam pro or your foam controller on the pump panel. That's going to give you a gallon per minute reading of every gallon of water that flows into this pipe that feeds all of your various foam outlets. Now refresh my memory here. We've got a deck gun that has foam. We have a rear 2.5 with foam. We have 2 pre-connected lines with foam. That's it? That's 4 of them. So this one shows a few other options of things that we do, but you can basically think of this as your 2 pre-connects. You can think of this, here's your deck gun, and we'll just, we'll cross off the hose reel, and we'll just call this here your 2.5 inch to the rear. But with those 4 outlets, as soon as you start flowing water to any of those outlets, and you open up any one of those 4 valves, this paddle wheel is going to start to spin, and it's going to send a signal to the Foam Pro display. And I'm going to just quickly draw what that display looks like here on the pump panel. On the pump panel, there's going to be a device. It's going to be a black box, and there's going to be a display here in the middle of it. Okay? And that's going to read your GPM. Let's just say 60. is what it's gonna be showing for GPM. Up in that upper left-hand corner, there's a red button, okay? And in this corner, there's another button called Select. And down in these two cornered buttons, you have a down arrow and an up arrow. Okay, this is the Foam Pro controller that reads this flow meter. When it starts to spin, it's going to send a signal to this device telling you exactly how many GPM are going to any one or all four of those different lines. Okay? If we don't push this red button, all of those lines are going to be just plain water. But this flow meter is still going to tell you how many gallons per minute are going out any one or all four of those lines. But as soon as you push the red button, that now turns the foam system on. It actuates the valve, or the foam pump, and this little red light right on this part of the display will come on as soon as you push that red button, telling you that the foam pump is on and ready to go. And if it's reading any gallon per minute reading here, as that paddle's spinning, that water is going to be traveling through this pipe here, through this check valve, and I'll explain that reason for that check valve in a second. But the water's going to flow through that check valve, and if this red button is pushed on, it's going to tell you how many GPM are flowing by, and it's going to draw foam from the foam tank through a foam pump and pump it into this fitting, and then that water and that foam are going to travel through that pipe. And just to kind of show by color here, we've got yellow foam coming from the foam tank, and then when that yellow foam hits the blue water, we're going to have a foam water solution that's then going to transport itself into all of these various outlets. It's going to fill up your entire manifold going to all these various lines. Okay, now we have foam water solution to all those lines. Just by pushing a red button, you've now made all of those lines foam. And they're all going to have the same exact mixture of foam to water ratio. And it's going to be whatever this device is set at. The standard for compressed air foam is going to be 0.3%. Okay, so that standard setting, if you push either of these up or down buttons just once, that's a quick way to check to see what your setting is at. And it'll come up and it'll probably tell you 0.3% or 0.3%. That computes out to for every 1,000 gallons of water you use, you're going to use 3 gallons of foam. Okay? So that's what 0.3% is going to mean to you in actual numbers.
Troy,
Yes.
if that unit, is it always default to 0.3%,
Yeah.
or does it default to what the last setting was?
It will default to whatever is set in that default code, and I think it's a 0.3% right now. That's what we set at the factory for calves. Now, the only time you probably would want to change that setting is if you wanted to make a foam, a really thick, heavy shaving cream foam that's going to last for hours and hours for exposure protection. You might bump that up to 0.4 or 0.5%. Going much more than that, you're wasting foam. You can do so much more just by increasing the air and fluffing up the foam to make it last longer. You don't need to add a whole lot of more foam concentrate to make the different types of foam. But there's some wildland guys that still swear by going up to a full 1% for Class A foam, but they probably don't have the compressed air foam. They have an aspirating type of a nozzle, and they want to try to make that foam last as long as you can. The more building blocks of foam you have, the thicker the wall of the bubble. Therefore, supposedly the longer that bubble can last because it has a stronger foundation. But by making a stronger foundation of foam around the outside, you also create a heavier wall weight, and the bubble weight will actually start to settle. The water in the foam will settle towards the bottom, causing an irregularity in the surface, and it will actually pop the bubbles faster because the foam has more, because the bubbles are made up of a higher concentration of foam. The thinner you can make the wall, and the smaller you can make the bubble, and pack them in and just make a heavier shaving cream, the longer the foam's going to last. And you do that by reducing your water flow and increasing your airflow, but still leaving your percentage at about 0.3, 0.4%. 0.5 is probably the heaviest I typically try to run, unless we got a foam system that's out of calibration and you have to cheat the calibration by turning it up a little bit more, or orifices that start to become clogged over time so it doesn't get as much as it thinks it's getting. But on this type of system, we don't have problems like that. The calibration, once it's set, it retains that memory and lasts a long time. And there's really nothing to plug up. There's nothing that really needs a consistent flushing once every couple of years, maybe run some water through the foam pump just to kind of flush out the pistons, but even that's rare. You gotta really be, in a really hot climate for that foam to start to dry up in those foam pumps. But to get back to it, as soon as you turn this red button on, water flows past the flow meter. It sends a signal to the foam pump to start pumping enough foam in to meet the need for that 60 gallons a minute at 0.3%. And it's gonna just kind of every once in a while turn its motor and squirt a little shot of foam into that manifold so that it keeps that percentage right at 0.3, and it's very accurate. But all of these lines are gonna have the same foam percentage. One question that some people come up with is there any way I can make a 0.5% mixture on this line and a 1.0% mixture on that line? That's not possible. There's one metering valve, and that's here in this digital display, and it's always going to come up at 0.3. Even if you push this arrow 10 times and move it up to 1.3 for whatever reason for that scenario, if you shut the master switch off in the truck and go out for your next call, it's still going to default back to 0.3. So you don't have to worry about changing it back every time. And from a flushing standpoint, not to jump ahead, but from a flushing standpoint, when you're done using the foam system and you want to shut down, flush out, and go home, all you have to do is push that red button again, which will turn off the red light, open whatever discharges you were just flowing foam, and just wait till clean water's coming out, shut your lines off, walk your hoses out, and you're done. You don't have to go back and flush out the foam tank line and flush out the foam pump. All you're doing when you're flushing is flushing from this point, and there's a small little check valve, right here at this point where that foam gets injected into. There's a small check valve there, and that line from the foam tank through the foam pump to that water foam manifold, that remains constant 100% concentrate all the time. You don't have to flush out this part of it. What you're flushing is just the piping, your hoses, and your nozzles, so that they're not sticky and have foam left in them, okay? So we turn the red button on, we got water flowing past the flow meter, foam's getting injected, the water and the foam are getting transported to all these different locations, and then each individual discharge line is going to have a control valve up on the pump panel that you're going to control the water and foam flow, the liquid flow. That's the variable component that you have, and then what you have is an air line. Now we're going to get into this air manifold here, which is distributing air to all the various different locations that can make compressed air foam. And what these lines show is two different options. You can either have an inline valve that's preset with an electric toggle switch control valve, where on the pump panel what you see is your control valve for adjusting your water foam solution, and then a toggle switch above it. And what that toggle switch does is it sends an electrical signal to an electric valve that opens the airflow in through a check valve and into that pipe where that foam water solution is coming through. So this is all this is a blown up version of like what you see right in here, okay? It's just showing it the opposite direction. But you'll take air through a solenoid valve, it injects into that check valve right here, and then that foam water solution travels through that pipe and then mixes with the air, and out the end comes compressed air foam. Now there's a check valve both on the foam water solution here, so that your foam water solution that's coming through, and then the air that's coming in the top here, I'll show that in a different color just for clarity's sake. The air that's coming from this upper manifold, this whole air line is charged. The air coming through this preset valve comes through the solenoid valve, and then there's another check valve here. So this check valve keeps water and foam from getting back up into the air compressor, and this check valve here keeps air from getting back into the main water pump or into the other CAPS discharges, which could then vary each different type of discharge that much more. So it makes what type of foam coming out this nozzle specific to that hand line or that nozzle or that deck gun. It makes it specific so that you can make a wet foam off of one hand line for firefighting, but a really nice dry fluffy shaving cream type foam off the next line for exposure protection or covering a building or covering shrubs or trees. You can make different types of foams at the same time just by controlling your water and foam volume and your air volume to that line. Okay? Now, in that air injection line, like I mentioned, especially on your two pre-connected lines, your two cross lines that pre-connect with the 1 3/4 hose, there's a valve inside the pump compartment that's variable, but we preset it at about 60 CFM of compressed air. And that 60 CFM compressed air is enough air to do both jobs for you. It's both gonna make a really good wet firefighting foam, but it's also enough foam to make a good dry shaving cream foam. And all we do to make those two differences is we close down or we open up more our main waterway valve that's flowing the water and foam solution. We flip on the toggle switch and we make whatever type of foam as a result of how much liquid is traveling along with that air. If we close it down a little bit, you'll see that there's a dryer arrow on the pump panel by those two discharges. If you just close down that valve a little bit and reduce that water flow, you'll end up making a much fluffier shaving cream foam. And commonly you can go down to as much as 20 gallons a minute or 25 gallons a minute to make a really dry shaving cream foam. With that 60 CFM of air, it makes a good foamy mixture. Now that same 60 CFM of air, if we increase that water volume from 25 or 30 gallons a minute, and we can see all that right on this display as we open and close our lever, as we open that valve a little bit more and get it up to about 60 GPM, along with the 60 CFM of compressed air, now we've got a really high velocity, milkier, wetter type of foam, but it's a high velocity foam that's gonna really absorb a lot of heat and knock down a lot of fire. That's 60 gallons a minute, coupled with 0.3% of Class A foam, along with that 60 CFM of air that we trip with this switch when we turn on the air, is gonna come out of that nozzle, in a hurry. And it's gonna knock down as much fire and absorb as much heat as about 200 GPM of plain water through a fog nozzle at 150 PSI. So that type of heat value can be knocked down with only 60 gallons per minute of water leaving your truck. And a couple of shot glasses full of foam is all the foam you're using. So, after you use 1,000 gallons of water, you've only used not even a full 5-gallon pail of foam. So you guys are familiar with foam. You see some other vehicles out there with compressed air foam, so you understand some of that already. Yes.
So where is that valve that you guys set at 60 CFM?
That is right inside one of those
On the side?
two
It's on
side
the
panels.
side.
Yeah, left side panel.
Okay, I just want to make sure that was the valve I was thinking about.
Yep, and there's two of them. One of them will be labeled in a red color. The other one's labeled in a blue color to match the labeling on the pump panel. And they are adjustable. If you guys want to tinker with them,
Right.
and you want to flow more than 60 CFM or less than 60 CFM, you can adjust those once you flip your toggle switch and the nozzle person's opened the valve out on the end. You can adjust those and tinker with them a little bit. And you'll just have to know that
These are on the pre-connects.
these are on the two
Yeah.
pre-connects.
Okay, I was a little
Step
lost.
auto cast.
No, right, got it.
Yep.
I'm with you now.
And those valves, it'll be a trim plate such as this, and I think it says airflow across the bottom. And all it is a chrome knob, something like this, and there'll be I think it's closed here and open here, and there'll be an arrow on your valve, and there's a bunch of graduated marks all the way around this valve like such. And one of them will say front pre-connect or rear pre-connect. It'll be either in a red color or a blue color. And where we're gonna have those set right now is basically about 60 CFM, which is darn near one half of its, full open position is roughly about 60 CFM. And that's about perfect for mixing with that 60 GPM of water for a really nice firefighting stream, a really high velocity, hang on and point it at the fire and you'll be amazed how fast it goes out kind of a stream. But that's about where we set it. It's about halfway open, and you can look at your flow meter when you're standing up at your pump panel, okay? You've got all your levers here and all your levers over here. On this little side wing right here, built into that box is gonna be your flow meter with a bunch of different graduated lines. And as you open and close these various valves, you're gonna notice that red line go across that grid at different locations. And we have it set right now. When you flip that toggle switch for that speed leg, this thing's gonna jump up to about 50 or 60 CFM because that's where we have this valve set, okay? And you can adjust that. If you turn it open a little bit more, that line will go up a little bit more, you'll get a little more air in that line, and it'll make a little fluffier foam, or it'll discharge a little further. But there's a point where you can open up this valve more and more and nothing's gonna change because the hose can only hold so much stuff, okay? If it's already got 60 GPM of water traveling through it, there's only so much space left in that hose to add compressed air. And surprisingly, it's right about 60, 65 CFM in an 1 3/4 line. If you try to get more air in there, Your water flow might drop off a little bit and you might get a little more air in there, but there's gonna be a point where water's gonna win. Water's gonna win because it's a non-compressible solid liquid. If it's already traveling through the hose, you're only gonna be able to force so much compressed air into that remaining space, okay? So if you open that valve up on your pump panel right here, you crack open that speed line and you open it wide open. And this flow meter up on that pump panel, which is about here, I believe, if it starts reading 120 GPM when you open up that lever and that nozzle person's blowing a bunch of water and foam out on the ground, when you flip that switch to turn on the air for that line, nothing's probably even going to happen. You might see a little bit of a difference in the stream. It might get a little foamier, but you're not going to see any change on this flow meter display on the side of your pump panel because it's full of liquid. You've really only got about 120 or 125 parts of space left in an 1 3/4 hose. You can either get in 120 gallons a minute of water, or you can put in 60 gallons a minute of water and 60 CFM of air. If you've got 80 gallons a minute of water going through it, it's only going to have room for about 40 CFM of air. And that's just physics. That's just space. That's just all you can do with that hose line.
And that's an inch and 3/4, what about 1.5?
It's not all that much different. With compressed air foam, the 1.5 inch, 1 3/4 numbers really don't vary that much.
Okay.
And that's where I kind of threw out that 125 number. The 1.5 it was always about 120, but if you go to 1 3/4 hose, you get about an extra 5 parts of something in there. And it's negligible when you're looking at, graduated lines that are 1/8 of an inch apart,
Right.
You're not going to see that much of a difference. You can still kind of pretty much figure you get 120 parts for either 1 1.5 or 1 3/4. Now the 2.5 or the deck gun, that's where things get more interesting. Because as a pump operator, these speedlays or these pre-connected lines, they're a breeze. You just open that valve up somewhere in that calf's range, which is labeled on the panel. You just bring that thing down to about a halfway open or about a third of the way open, and you're right in the ballpark. You flip a switch, the foam system's on, you're making great calves. You're going to knock the fire down in a big hurry. The 2.5 inch line for the rear discharge of the deck gun, those get a little more challenging. They're a little more fun because now you get to decide how much water and foam you want to actually flow. And when you actually look at this airflow valve is going to be mounted right on the pump panel with a knob right on it, instead of having a little toggle switch here or a toggle switch here for those two lines. This actually has the airflow valve on the pump panel, so you can decide exactly how much air you want to put in. Now with a 2.5 inch line, surprisingly, it's about double to a little bit more than double what you have with an 1 3/4 line. So if you can get 120 parts of stuff into an 1 3/4 line, you can get more like about 250 to 270 into a 2.5 inch line, depending upon what type of hose it is. Some of those solid rubber hoses flow different than even a double jacketed type of cotton woven hose. But the 2.5 inch lines, I really see those primarily being used to feed ground monitors or feed other vehicles or feed aerials with compressed air foam or pump into standpipes. It's not very often that I really see fire departments taking a 2.5 inch hand line with a nozzle and trying to go in and fight fires, because there aren't too many nozzles that are made 2.5 inch diameter for calves firefighting. Okay? The important thing about our 1.5 inch nozzles, okay, we got a coupling, we got a valve body, we got a ball inside of there, and then we've got a couple of threads out here on the end to hook our nozzle to, and we put our smoothbore tips out on the end of here, and they slightly taper inside, and then we've got our gate valve on the top and maybe a pistol grip here on the bottom to grab onto. But the important thing is with that ball valve, when you get that valve wide open, we got nearly 1 3/8 inside diameter all the way through that ball valve. Okay? The funny thing is when manufacturers go and give you a 2.5 inch nozzle, they use the same exact ball inside of that bigger valve body, and you don't gain anything as far as flow when it comes to calves. Calves is made in the hose. Okay, you get your water and foam and your air that mix here at this point, and then they travel to the outlet, you hook on your hose, and the bubbles all get made as they travel through the hose linings. The more hose you have, typically the better the foam bubbles that are getting made inside. Okay, 50 feet's pretty much the minimum, and you might notice with a 50-foot line, it's a more sporadic type of foam that sprays out the end. But with a 100-foot or 150-foot, you get great foam all the time. But with a 2.5 inch, all that foam that's being made in that 1 3/4 or 1 3/8 or 1 3/4 line, all that foam that's being made, slightly when it gets coupled to this 1.5 inch nozzle, it slightly has to squeeze down that foam when it hits this 1 3/8 orifice. And then if you don't have any tip on here at all, that's your best foam making capability for the really fluffy foam, if you take the tip right off. But most of the tips we go down to maybe 1 1/4 or 1 1/8. Some people even go down smaller than that with calves. The smaller you go down, the more it's going to squeeze those bubbles as they're traveling through that nozzle and pop some of those bubbles as they travel out onto the fire, which is going to be fine for firefighting. But if you're really trying to make the really fluffy, the fluffiest foam possible, you want to almost screw all these tips off and just let that foam come right out of the end of the open butt of that nozzle, so that you don't put any added restriction on the end of that stream that's coming through. Now imagine if you got, and that works great if you got 1 3/4 hose coming right to it, so it's not changing the total space that foam has to travel through. But now figure if you've got a 2.5 inch hose that's coming up here, and you've got a bigger coupling on the end of your nozzle now. Now you got a 2.5 inch hose, and all your foam bubbles are being made all the way out through here. Now, right at the last minute, they've all got to turn around and go in through this 1 3/4, 1 3/8 type space. All those bubbles are going to quickly have to change in size and shape. It pops most of them, and what comes out the end of the nozzle is pretty much a waste. So the whole fact of changing to a 2.5 inch hose and putting the same nozzle on it for firefighting, you might as well just use an 1 3/8 or 1 3/4 hose and not waste having to carry around all that extra weight of hose, because you're not gaining anything. Your nozzle is still going to determine the type of foam that comes out the end of the nozzle and the quantity of it. Okay, if you put that same nozzle on the end of a 2.5, you're going to still get basically a 60-60 mix, because that's going to determine how much can come out at the end of that nozzle. They do make nozzles, and we have them in our catalog now, that are a 2.5 inch ball valve.
We have one.
You do have one of those?
Yes.
The big,
Gated ball, it's basically just a gated ball.
Cannon.
exactly, cannon. It doesn't have a pistol grip on it, so it's something where now you got to figure out how you're going to hang on to it. But it has a full, it's about 2 1/8 inch opening through the inside, so it's still necking down quite a bit. But overall surface area is quite a jump up over that 1 3/8 ball. So I mean, if you really have a heavy fire load, and you can get a couple of people out at the end of that nozzle where you can hang on, it's like a portable deck gun cannon right in your hands. And it's something you got to hang on, because that tip that's on it comes out here a little bit further, but it still has, I think, a 2 inch opening on the end. So that's quite a cannon to hang on to. But that's one of those things where I would probably run that at about 120, 130 gallons a minute and 100 and some CFM, somewhere in there, and just kind of tinker and see where you can still hang on the line and maybe give it a little more liquid. But that's going to be quite a cannon. And then the same with the deck gun. The deck gun, you can give it a little more because it's permanently mounted on the vehicle. You can go up to around 200 and some gallons a minute and still get 200 CFM through it, because it's actually plumbed. Even though it's plumbed 2.5 inch, it's got a 3 inch pipe once it gets to the deck gun, and then it goes through the deck gun swivel and then out the end of the stacked tips. And if you take the first couple of stacked tips off, that deck gun, for the deck gun, you can probably get about, I say up to about 250 gallons a minute of water, and sometimes you can even get over 200 CFM of air. But that's going to be a heck of a blitz attack type of a stream there.
That's the capability of our.
That's pretty much one of your maximum, yeah. And that's through that inch, and I like to take that to either the 1 3/4 or the 2 inch tip for the deck guns. And if you put the smaller tips on there, again, you're going back to basically getting the maximum flow of the tip size, which is getting back to your 1 3/4 hose line or your 1.5 inch hose line, depending upon what tip you use. You're really having to force things through a smaller orifice. Calves is all about bubbles being made in whatever size pipe or hose they're traveling through, and you just want to let them exit without a whole lot of change in pressure.
Troy, on your deck gun, do you have a mixer because you don't have the hose length?
Yep, you do.
Okay.
That's why on the deck gun, glad you brought that up. As that foam water solution goes through the valve for the deck gun, here's your control valve that'll be on your pump panel for giving your water to your deck gun. It's going to go through that check valve so that the air can't get back into here. And then the water and foam is going to get to here. Your air is going to come in through that ball valve on your pump panel, Air's gonna come in, it's gonna mix with the water and foam, and the first thing that it runs into before it gets to the main standpipe riser that goes to the deck gun is this motionless mixer. And that's basically it's a friction loss creator. Because your deck gun doesn't have the luxury of having a hose connected to it, we have to find some way of churning up that water, foam, and air mixture. And we do it in about a 14-inch stainless steel chunk of pipe with a bunch of opposing stainless steel discs. And it just forces that water, foam, and air to travel through a bunch of space and churn it up so that when it comes out the end of the nozzle, it's actually making good foam bubbles. Okay? The problem with that motionless mixer is if you put that in there and you try to run plain water through that piping, it's going to cut back on your maximum water flow capability. Okay, so you're not going to get as much, you're not going to probably get your 1,250 or 1,000 gallon a minute rating through that, because this thing creates a ton of friction loss, but it's designed to churn up and make your bubbles. Okay?
That's why it has another.
That's why,
I understand that.
that's why you have this other valve here
Yeah.
for plain water. And that's the one you want to use if you want a lot of volume.
Mhm.
If you want to make calves through the deck gun, then you use your other option. But now you can also use both of them in conjunction if you want to. Keep in mind that if you open up the water valve along with your calves or your foam valve, you're going to dilute your foam mixture. Okay, you're not going to get as much foam, so you might need to bump this arrow up to 0.4 or 0.5 or 0.8% just so that you actually get a 0.3% mixture when you start flowing. The only time you need to do that is if you're running, say you're running your calves line. You got it all the way open to where you think you got a good mixture. You got your air flowing, you got as much air as you can get, as much water and foam as you can get, and you're coming up 10 feet short of what you're trying to hit. Maybe the wind is pulling it a little bit or something. You're coming up a little bit short. We don't want it to move the whole truck, so just grab your turbocharged water valve for your deck gun and just crack it open a third of the way, add a little bit more water weight, bump up your foam percentage so that it can keep the foam percentage up there. Next thing you know, you'll be shooting over your target 10 feet. I mean, it adds that much more throw distance just by adding that much more water. Okay? And that, it does work nice. It's basically like having a gated Y inside your pump compartment with two different ways that you can get liquid to that spout, essentially. And you can run either of them together. You can run, one without the other, or like I say, both of them at the same time. It's not going to flow water backwards into the pump and cause all kinds of problems that way. The liquid that's coming straight off the water pump has less friction loss than the foam that has to go through the check valves, through the motionless mixer. So your foam isn't going to get back into the pipe, into the main water, because the water coming this way is going to be able to travel quicker and travel more easily. It's a path of least resistance for that water pump to just spray the water straight through that 3-inch deck gun. Now, where you might find is if you shut the foam valve off first, and then, or actually shut them both off at the same time, you might find that any foamy water left in this pipe, when you drain it back down, might get back into your main pump head. But even that's pretty much negligible. You're talking about such small quantities of foam that it's not going to, require any flushing. You're talking 0.3%. It's hardly even noticeable in the water when you're dumping it on the ground, unless you're, aerating it with that compressed air. It's hardly even enough to make a really bubbly mixture without compressed air. Does anybody have any questions on the plumbing circuit itself? How things are taking place? Yeah.
Just a simple question on your left diagram. Is that, when you add it to the left, is that where the recirc is? Is that what you?
Over here, your tank
Yeah.
refill, yeah, that would be your recirculating valve, so you can run water back to your tank and not have to worry about foam going in your tank. I don't know if there's an automatic pump overheat system on the truck. I don't
It's
think.
not like,
Is there a light? Because then not only do you have, the tank refill is a nice way to always know you're recirculating water from your pump back to your tank, and then it's always picking up water from the tank to pump back into the water pump. That's a nice way to just kind of crack it a little bit and know that you're always keeping your pump cool, because you're recirculating fresh water through all the time. Tom said he mentioned he did notice seeing a red light on the pump panel next to a pump overheating label. I can't remember for sure, but if it is on there, what we have is a temperature probe built right into the suction side of the pump, and if it shows that the impeller water temperature is getting over 120 degrees Fahrenheit, it'll automatically pop a solenoid valve, and it'll discharge water back into the tank at about 2 or 3 gallons a minute, just to keep that pump water from actually boiling inside, even if you forget to open the tank refill, or if you go away
It
from
has
the
an
engine.
alarm too.
I don't know as though the alarm is necessarily hooked into it, but there'll be a red light that comes on, and there may be a buzzer.
It does have it, and I think it,
Yeah, the buzzer does come along with the kit, but sometimes it gets installed, sometimes it doesn't. I think it will. When that system is up and running, that buzzer, you can just kind of faintly hear it if it's buzzing over the sound of all of the other engine noises and air compressor sounds and the hydraulic sounds. But yeah, there's a little red light. That'll indicate that it's come on. And if it does come on, what I recommend you do is crack your tank refill and quickly get that warm water out of the pump faster than that 2 or 3 gallons a minute that we're doing it through the overheat. And then once you get that temperature down under 100, then that light will go off and it'll reset itself. Okay? But that's a nice protection to have so that you don't end up having a major pump failure or start pumping 180-degree water out your nozzles and somebody out there gets a real nice sauna bath of warm water.
I think as a matter of just procedure, we're gonna teach people to.
Crack the tank refill. Yeah, and that's what I put in all my training manuals also, is just crack it slightly. And the reason being, we'll come up to when we talk about the air compressor system, why it's so important from a cooling standpoint for the pump to make sure that we're always recirculating a little bit of water back to the tank. That pretty much covers it on these 2 schematics, other than there's an automatic pressure control valve here that gets a water pressure signal from that pump, that foam line, as well as a pressure gauge that would tell you exactly what the pump pressure is in that line. But what I'll hit on here next is your air compressor.
Hey Troy?
Yes.
Question again. Is the boiling temperature in the pump, does that change with our altitude up here?
Oh, I'm sure it does something somewhat. It kind of,
Water boils here at, like 99 degrees or something.
come on, it's not that much, is it?
It's not that much, but it's considerably low.
I know it is less.
Is there a chance that it would boil before that light will come on?
That's 120, not
Oh, I'm
can't-
sorry. Is it 120?
120 is when
I'm
it
sorry.
comes on and goes, but I can't. Your water isn't gonna be that much different in boiling. I mean, you're 212.
Yeah, we're at about 200.
Yeah.
Yeah.
That's
It's
kind
100
of
degrees
cool.
off, so ignore it.
No problem. That is a good question. Now I learned
99
something today.
degrees.
Now, 120 when we send,
Yeah.
when we send the truck to Grand Junction next summer,
Yes.
Right.
Yeah.
the
When you-
water in the
when you-
tank's about that.
Yeah, exactly. Yeah, it will make a difference in what your tank water is, how fast it gets to that point, no doubt about it. What we have here is the air compressor schematic. These are the components that make up the compressor system. And now, it's not important that you understand every single component or what it does, but I've got a pretty good feeling that if you have any ability to understand a little bit of the technology, I can pretty much teach everybody what's taking place here and have a really good understanding of what these components are. Because, I mean, essentially you have an air compressor here. Here's a top view and a bottom view, or a side view of that air compressor. It mounts right to the gear case that drives the water pump, okay? You have a PTO-driven gear case that drives the water pump and the air compressor. So the PTO that's on the top of your transmission that drives the vehicle is a PTO, a power takeoff, which is basically a set of gears with a drive shaft that goes back to the pump. When we shift in the gears for the compressor, that ties the compressor drive to the pump drive gears, essentially. And it's a mechanical sliding gear that actually connects these 2 together. So it's very important that you always shift the compressor into gear before turning on the PTO to shift the pump, okay? We've already set it up with an interlock so that if you do shift the PTO first, and you start spinning the water pump gears in the impeller and start pumping water, if you try to shift the air compressor into gear in the cab after that, it won't go into gear. It's just not going to happen. So that you can't wreck things. But you might be back at the pump panel flipping your toggle switches or opening your airflow valves going, why am I not getting any compressed air? I've got it engaged in the cab. But not until you shift the PTO out will the compressor actually go into gear. Okay? So from an operational standpoint, you have to shift the compressor switch first, and it's on the top of the 2 levers. Shift that one in first, and incidentally, you could leave that on all the time and keep it coupled right to your water pump gears all the time. If you knew that your standard was going to be fighting fire with foam and compressed air foam, you could save 1 step in the cab, which is, I mean, you're talking a quarter of a second to flip the switch, but you could leave it engaged all the time. It's not going to do anything damaging Other than having an additional green light on every time you're driving down the road, it'll show that that compressor's already engaged the pump. But short of a, you know, a light bulb burning out a little bit more often, that's about the only downside to doing that. Otherwise, shift the air compressor, then shift the PTO for the water pump. Now we're spinning the whole works. And when this compressor is spinning, it's going to draw oil. Because it's a rotary screw type air compressor, it's going to need oil for lubrication. Okay, this air compressor has the capability of putting out a total of 220 CFM. Now, I want to let you all know, and this is where I get to kind of put a little feather in my cap, is I've done you guys all a favor, because when you ordered the truck, you ordered a system, I believe it was only our 120 CFM compressor system, is what our salesman actually sold you, was our basic AutoCAFS 1 120 CFM compressor system. But I know that if I'd have put our Bauer 120 CFM compressor system in this truck, at this altitude, you'd have been lucky if you'd have got 80 or 90, okay? We have a 220 CFM compressor that's rated at sea level, so realistically, we probably more like have, I would say 180 to anywhere up to maybe 195. I don't think it's going to do much more than that, really up here at, what are we at, about 8,000, 8,000?
73.
I don't think it's going to do more than that, but I am curious to find out now that I'm here to exactly see what it will put out at this elevation. But that CFM is quite a bit exceeding what was originally spec'd with the vehicle. But not to over harp on that, but I mean that's a tremendous air compressor to have available for these 4 discharges. You could run both of your hand lines and either your deck gun on your or your 2.5 at the same time. But even just being able to run both those hand lines and your 2.5 at the same time is a really tremendous punch that you can put on a fire. We're going to draw the oil for lubricating this rotary screw compressor. These 2 rotors are spinning like a blower on a high-performance car engine. They're drawing in air through this air inlet valve, compressing it and dumping it out. But it's doing this at 3 times pump RPM. And pump RPM is about 2.5 times engine RPM. So if your engine speed's 1,000 RPM, that's going to put your pump impeller speed at about 2,500, which puts your air compressor up around 7,500 RPM. I mean, those rotors are cooking, they're flying. So they need oil for lubrication. And we get that oil from this large reservoir tank that's located on the passenger side, of the right side of the vehicle, behind that panel when you open up that panel side. That oil reservoir is going to supply oil through this line. That oil is going to travel across into a fitting on the side of the heat exchanger oil filter combination. If the oil's cool, if you've just turned the system on, the oil's going to go right through a thermostatic valve, through the filter, out of the filter, and onto the side of the compressor fitting. It will actually pressure lubricate the system, because as soon as it's turned on, it's going to start to vacuum in the oil that's in that line. But as soon as it dumps that oil that goes through these rotors, it gets dumped back out of this line along with any compressed air that it brings in, or any air that it brings in and compresses. It dumps that back out. I should probably change colors just so we know what the water and foam, oh, that blue isn't much of a color change. We take our water, our air and our compressed, and our oil. That air oil mixture then spins around inside of this upper part of that oil reservoir. Any oil that collects on the outside will drain back into the lower part of the reservoir tank. The rest of it has to go through 2 filters. These are separator cartridges, and they take away any of the remaining oil that's in that mist. These 2 cartridges then take away all that remaining oil mist. It's like 99.998% efficient. So you can run this thing for hundreds of hours and not notice any oil loss in the system at all. But it's darn near a perfect removal of oil. Then our clean compressed air comes out, and that's where it then feeds into this line to use to go to all your various discharges. Okay, that clean compressed air also goes to a regulator, a secondary regulator here, which goes to different air tool quick disconnects for running air tools, nozzles, blow guns, air chisels, air drills, grinders, whatever you want to run off of those air lines. Now what I want to explain here is back to that heat exchanger where we're drawing oil from that bottom of that reservoir to the heat exchanger oil filter combination. If that oil temperature is over 170 degrees, if the system's been running more than about 10-15 minutes, that oil temperature is probably gonna get up over 170 degrees. As soon as it does, this thermostat snaps shut, forces the oil to go down through the oil cooler, and this is a multi-brazed plate type heat exchanger, forces the oil down through that cooler, and then it comes out of the cooler, back into the filter, and then onto the side of the compressor after it's been cooled and filtered. Now that cooler also sees water, a cooling water from the discharge side of the water pump, and then it goes back to the suction side of the water pump. That's always taking place, you can't do anything about it. There's about 1.5 gallons, 2 gallons a minute, up to about 3 gallons a minute at 150 PSI. That's traveling through that cooler and going back to the suction side of the water pump. It's always looping through. Even when your water, or even when your oil's 100 degrees or less than 100 degrees, that water is always going through there, and it's getting supplied by the water pump through a strained, self-cleaning filter, right, that's built right onto the water pump. It's the same self-cleaning strainer or water supply that we've used for years to supply clean, filtered water to our pressure relief valve system and any other that are very critical flowing type of water lines. If we had a heat exchanger, or if we had like in this application, a heat exchanger or a sensitive device like a pressure relief valve, we want a very clean filtered water supply. So we pull off of that strainer that's built right into that pump discharge head. So it's always self-cleaning. As the water flows past it, it picks up what water it needs for cooling, but it flushes away any rocks or pebbles or fish or toads or whatever else happens to get sucked into the pump. But we get clean water coming through that filter or through that heat exchanger, cools the oil, and then that water goes back to the suction side of the water pump. Now this is why it's important that we remember we always want to have our tank refill cracked open. Because not only, if we're running at 125 PSI, not only do we have the heat being generated by the impeller and the seal rings inside the water pump, if we're not discharging any water out onto the fire or out onto the ground or spraying into the trees or whatever, if that pump is bottled up and not discharging, but it's spinning, it's creating heat. The impeller, the seal rings. Now we also have heat being transferred from the air compressor oil to that water that's being recirculated in there because it's cooling that 170 degree oil. So it's going to warm that pump up just a little bit quicker than it would have normally. So that's why it's important, like you mentioned, to always have that recirculating valve or your tank refill just partially open so that you always know you're getting fresh water coming from your tank, going through the pump, cooling the air compressor, cooling the impeller and the seal rings, and then going back to the tank refill. And that'll keep everything lasting much, much longer and keep the water much cooler so that when you're fighting the fire, you're doing it with cool water, not with 170 degree hot water or something like that. Any questions on any of that so far?
Are there any filters in there that need regular maintenance?
That's a good question. Let me hit that as the very last thing.
Because
There's
also,
three
the oil,
filters.
do we have to do anything to maintain the oil?
With,
tank?
with the oil filter change once every year, once every couple of years, we recommend an oil filter change. But that's going to be purely based on number of hours. I mean, you don't have to change this oil every year if you've only used the thing 20 hours. This oil is designed to last for, 1,000 hours of end-to-end running. Actually 10,000 hours, excuse me. This same exact air compressor system's used in industries for supplying air to switching systems and relays for, conveyor belts and you name it. I mean, this is a high quality industrial type air compressor system. At 220 CFM, 7 days a week, 24 hours a day, end to end for 10,000 hours, they run these things without shutting them down to change the oil and filter. But they are in a situation where they have clean, consistent temperature air with, through, super filters. They have a climate controlled room. They have a lot more going for us other than the dust and the butterflies and the bees and the dirt and the smoke that's in the air where we're fighting fires. So we have a much harsher environment to deal with. So therefore we've set more stringent maintenance guidelines. We'd like to see the oil filter and the oil changed every year, but if it hasn't hardly been used, it's overkill. I don't like to see people waste their time or money on oil and oil filter changes if it's not necessary. The most important filter in the whole system is your air filter. This is going to be the most important filter because it's the first line of defense against the dirt that's out around us, that's being drawn in at a possibility of over 200 and some CFM, cubic feet per minute, into the system where that air, if it's filtered, it's nice and clean, it comes in, and none of the debris has to get saturated in the oil and doesn't end up plugging up the oil filter over time. But if you're out and you're working in smoke and dust and debris, I recommend changing that oil filter as required, as needed, due to elements, due to climate. That might be every couple of weeks if you're fighting wildland fires.
Yeah, what about the air filter?
That's the one I'm referring to.
Oh, you
Is
said
that
oil
air?
filter.
Well, did I say oil filter? I'm sorry. I meant air filter. If you take care of the air filter, that oil filter does not need to be changed any more than yearly, or every couple of years. I mean, if you have minimal calls or minimal, dirtiness in your air filter. But if you're going out and you're, pumping and rolling down dirt roads, if you're downwind, the wind changes and you end up pumping smoky air through that filter for a couple hours while you're fighting a fire, you might want to pull those $20 filter cartridges out of there and replace them every couple of weeks or every couple of months or maybe twice a year at least, But if you're not using the system and if you're not, if you're in someone's driveway and you got nice clean air and the smoke's going away from you, that filter's not even going to see hardly a speck of dust, So it's really going to be determined based upon your service use, how you use that vehicle. But you can easily spin a wing nut off the end of that cartridge, and we'll check it today. We'll pull it out of there and show you how easy it is to look at that air filter. Pull the cartridge out, look at it. If you're going to blow it out, I'd recommend a really, really, really low pressure, much more than a puff of being able to pinch your cheeks together and blow it by, just using your mouth pressure. Because if you tear a hole through that paper element, you're going to do a lot more damage than what you would have if you'd have put it back in there dirty. But, picking out the grasshoppers and the bees and vacuuming out the container and getting out any butterflies or whatever shop rags that might get sucked up in there while you're pumping, those types of things. If you can keep that cartridge clean and keep that filter clean, you're not going to have to do much maintenance on the oil or the oil filter at all. And even if you do change the oil in the oil filter every year, you're looking at $30-40 for the filter and the oil, and $20 or $30 for the air filters. You're not talking about big dollar items. But if you neglect your air filter and it gets your oil dirty and your oil filter's dirty, to where your oil filter decides to bypass, and now we're pumping dirty oil through the compressor, which is going to start to wear on the tolerances of the screws, and then that dirty air, compressed air with oil gets back up into the top of your separator, and it starts to plug up your separator cartridges. Now your whatever CFM compressor, let's say it's a 190 CFM compressor is all plugged with dirt in your separator cartridges. Now it might only be 170 or 150 CFM compressor. The more dirt that gets past the oil filter that gets into these separator cartridges just causes you a lack of airflow on the other end. If you notice a major decrease in air output at a consistent RPM, you test it one day at 1500 RPM and it's a 200 CFM air compressor, you test it a couple of weeks later, and it's only 150 CFM air compressor, but you're at the same RPM, you're at the same elevation, everything's the same. You never know, maybe you've got a piece of paper or something that flew into your air cleaner, or some debris is starting to plug the system. If it's consistently diminishing in air output, you might look at changing all your filters, including your separator cartridges. But these typically, those two filters, and they're both identical, they typically don't have to be replaced any more than every 5 to 7 to 10 years, depending upon how good you do the rest of your maintenance. But and we don't even have a system out in the market yet that's got more than 4 years on it that has any diminished airflow whatsoever to even need to change those separator cartridges. But if you do, those are the spendy mothers. Those are the ones that are a couple $100 a piece. So there's $400 in separator cartridges inside that tank alone. And that's the most difficult filter in the system to replace, incidentally, also. Is you got to take 2 nuts off the top of these 2 studs, pull this clamp off, pull this whole discharge head off, and then there's 2 Allen bolts that protrude through into the tank that are on sealed washers that hold those 2 coalescing filter elements in place. It probably takes about half an hour to change those 2 filters. But that's the most difficult filter to change. The oil filter you can change in 10-15 minutes, and in the air cleaner, I could say probably in 5 minutes you could change the air cleaner. Okay? Yes?
Wait, what's the nature of this oil? Is it standard ASE oil, or is
It's
it
a
a
standard-
special specification?
It's a standard mineral oil, but it is a hydraulic compressor oil. It's a 32 weight hydraulic compressor oil. But I haven't found a single oil supply house or lubrication house that doesn't have in stock or have readily available this type of compressor oil. It's used in a lot of different type of industrial compressors. okay? But it is a special weight, and that is all in the manual. There's about a 5 or 6 page section that describes changing air filter, changing oil filter, changing oil, the type of oil. There's a couple of different brands and weights in there that you can cross-reference. You know, if you happen to have a Shell dealer nearby, that's the type of oil that we use. If you don't have a Shell dealer, they can cross-reference off that number pretty easily. And it's not much more expensive than a typical, you know, ASE type of car oil. You know, it's just a little different weight and a little different makeup, so it's anti-foaming and some of those things, because when you're pumping it at such a high velocity, we're moving the entire quantity, this 14 quarts of oil that's in this tank, we're moving that entire quantity every minute through that compressor and back to that tank. So every 60 seconds, that entire quantity of oil has gone through the compressor and gone back to the reservoir. You know, it's really moving the oil through the system in a hurry. Yes?
The outlet compressed air, is it clean enough to breathe?
I don't recommend it, but I've done it before. But yeah, it is actually considered a dry, very dry, clean air. I would not start trying to think of, you can't, the pressures we're working at aren't high enough to even be considered for breathing air quality, but you could live off that air. I mean, it's going to have it's going to be warmer, obviously. It's going to be warmer than typical air, but it actually has been known to be breathable air. It's not recommended though, but it isn't, it's not a poisonous output of air. There's no carbon monoxide or any of those types of things in it. But it's going to have kind of a oily smell to it, I'm sure. But we've seen a lot of guys use that compressed air for, you know, filling up floating rescue lines, blowing smoke out of a building, blowing debris off the road, put a smaller nozzle tip on it. It's a lot of compressed air for blowing leaves, or you name it. I mean, pumping up tires, running air tools, grinders. It's a huge
General
air
house
compressor.
maintenance.
Yeah.
What is the output pressure?
Output pressure can go up to 150. You can make it higher than that, but there is a 200 psi safety valve, relief valve on the side of the tank. Okay, so at 200 psi, that's going to blow. It's going to release a nice oily, misty, pressurized air into your pump compartment. There's no reason that should ever blow, because right here is a manual pressure adjustment valve. Okay, and there's a little screw with a lock nut on it that we set at the factory at 150 psi. Okay, and then the last thing that I want to talk about here on this balancing valve is how all of the pressures get controlled. How does our air compressor know what pressure to make? Because anytime you're making compressed air foam, if you're putting in 100 psi, if your pump's running at 100 psi, your air compressor better be running at 100 psi. Volumes you control with your knobs and your levers on your pump panel or your switches. But the pressure that the system runs at is controlled by throttle. Okay, wherever you happen to be spinning your your chassis engine is going to determine what pressure your water pump makes. That, and also incoming pressure if you happen to do a hydrant or if somebody's relay pumping to you. But your water pressure coming to you is going to be controlled by RPM or outside sources. Your air pressure is controlled by water pressure. There's a water line from your pump that comes up here to the bottom of this diaphragm valve. That's the same as this right here. Okay, here's your diaphragm valve. That diaphragm valve, and here it's shown sideways, sets your air compressor pressure. Let's say you have 125 psi of water pump pressure. It's showing 125 here on your gauge. 125 psi coming here to the bottom of this diaphragm valve, pushing up on a diaphragm valve, which closes a port inside this path. There's an air path through this port, but it's being closed because it's got 125 psi pressure against it. You've just turned on your pump, you've just ran your pressure up. Your air compressor looks at that and says, okay, water pump's making 125. I'm only making 60 psi, which is going to be its standard startup pressure. It then opens the inlet valve. This air inlet valve that sits on top of the air compressor acts like the carburetor for the air compressor. Okay? If it needs to go faster or build more pressure, you bring in more gas, like through a carburetor. But in this case, we're bringing in more air. We bring in air through this carburetor or through this air inlet valve. It comes into the inlet of the compressor along with that oil, gets compressed, goes into this tank, builds up the pressure in that tank. But we're talking a very small tank here. This isn't a storage tank by any means. But it goes into this reservoir. That pressure is then read off of this fitting here, which comes up to the side of that fitting. And it's going to try to find its path of least resistance. The manual pressure control valve is set at 150. Okay? So our path least resistance isn't gonna be that because our water pump's only at 125. It's gonna try to push through this valve here, this opening, it's gonna push against that pressure that's being created against that diaphragm by the water pump pressure. Until it gets to 125, it can't overcome that pressure. So the air inlet valve is gonna remain open as long as the air keeps coming in and keep pressurizing the system until that 125 PSI can push past that diaphragm valve and get air pressure into this control air line. And as soon as we get any pressure in this air line, it pushes that piston inside that inlet valve closed and shuts off the air compressor so it's not getting any more air. And then it recirculates the oil and the air that's in the system. As soon as you open one of your downstream discharges, let's say to one of your speed lays or even plugging in an air tool to one of your quick disconnects, as soon as that pressure drops from flowing air, it's then closing off this port because this pressurized line here doesn't have 125 PSI anymore. As soon as that 125 PSI drop is noticed, this valve shuts. This pressurized control air drops to 0 PSI, which allows the inlet valve to open again, brings in more compressed air, brings the pressure back up until the pressure can overcome the diaphragm pressure again, and then it shuts the compressor down again. And this all takes place 4 times a second. Okay, so that inlet valve can open and close 4 times a second to make sure that that air compressor pressure is exactly what the water pump pressure is. That's how that balancing act takes place. So this whole area here, all these controls, act like the cruise control for the air compressor. If you want to think of this like the carburetor, it's going to base that pressure rating like speed for your car. If you set your car at 65 miles per hour, your cruise control looks at your speed. If you drop below that speed, it increases the throttle, brings in more gasoline, speeds you back up to 65. You start going down a hill, which we can call reducing our throttle pressure, reducing pump pressure. It now needs to blow down, or it needs to reduce its throttle setting. We can't open and close this we can't close this any more than fully closed. So what we have to do then is we use a blowdown valve, and we reduce the pressure in the compressor through a blowdown system, which vents off to atmosphere, and it'll hiss once in a while, and you'll hear a large kind of a hydraulicing sound when it's just pumping oil, because it's trying to get rid of any of the compressed air in the system, and it actually bleeds that compressed air down. And when it's just pumping plain oil, it'll be a much more hydraulically whiny type of a sound when your compressor's just pumping oil and not air. Okay? So all these components are like the cruise control for the air compressor. All they're trying to do, its only job is to try to match air pressure with water pressure. The only exception to that is if you're going to pump your water pump, you're just going to keep spinning your throttle or running your governor speed up over 150 psi. As soon as you go over 150 psi of water pump pressure, this now becomes the path of least resistance. The air can go through this T-fitting, push past this spring pressure, and shut down the inlet valve. So the maximum pressure that the air compressor should be able to make is 150, unless you go in there and you crank that knob on that air compressor, manual adjust a little bit more. But there's no practical reason whatsoever why you'd ever need to run more than 150 psi of compressed air. You sure as heck don't want to be making calves with 150 psi, because you're going to need to have 2-3 really big people on the end of that nozzle that can lean up against a tree while they're shooting that foam, because it's going to be a lot of nozzle reaction. So I mean 125 psi is really kind of the upper echelon of pressure that I recommend using for fire attack.
So this also means that if we're running air tools, or if we want to put air in the tires of our road bike, we got to make sure the pump is
has to be in
producing
gear.
enough pressure.
Exactly.
Not only in gear, but in recircing. If recirc's open too much, the pump's only making 60 psi.
Right.
We won't be able to get enough air to run the air tools.
Exactly. If
So
you
we
want to
gotta
run air
throttle
tools,
down the recirc to get the pump outlet pressure to be.
well, you'll still be able to get plenty of pressure. Even if your recirc's wide open, you could run your throttle and get plenty
Right,
of
right,
pressure.
we can
But
run it that way.
yeah, but even at idle, if you're at idle with your compressor and pump in gear and you're recirculating just a small amount of water, you'll be at about 40, 50 psi. But you will have to bring it up off idle if you want to get 100 psi of compressed air to your air tools. It's a very good point. But if you're at 125 psi and you're fighting fire and you're looking at the sticker on the side of your air tool that says do not exceed 90 psi and you're worried about it, be it known that you do have a secondary regulator inside your pump compartment that knocks down that pressure, and it's adjustable regulator, just like you'd have in a paint gun or any inline air tool, you can knock that pressure down to whatever you decide you want to have for your air tools. Okay? And I also want to make a note to all of you that one thing that a lot of people overlook is that 200 feet of pre-connected line with the nozzle on the end. If you take the nozzle off and put a cap on it and drill and tap that for a quick disconnect fitting, your firefighting hose is an air hose also. And you can pump plain air to any one of your lines without turning your water and your foam onto that line also. So if you actually, I mean, there's quite a few firefighters out there with caps that are taking their smoothbore tip off, putting it in their pocket, grabbing their other cap with a quick disconnect, plugging it on, taking their chisel for chiseling open steel entry doors that are locked, putting on a quick disconnect, you know, for, you know, running a drill or whatever else. And all you have to do, instead of opening your valve to supply water and foam to that line, just leave it closed and just flip your toggle switch. Make sure the hose is deployed or it's going to self-deploy for you. But make sure the air, that hose is deployed, and it's going to fill up with compressed air within a matter of seconds. And that's how you can make those, you know, a 200-foot floating rescue line. You can take that line, put a T in there, and make a big floating rescue donut, or, you know, float a line across a swift-moving river or something to grab somebody that's floating down the river that's out of control type of thing. There's a lot of things you can do with that floating line. And it doesn't sink like a rope. If you throw a rope across a swift-moving current, and you grab the rope, it'll just go right under the water. Flat floating hose, if you can grab a hold of that thing, it'll keep you above the water line if you have some, you know, some a little bit of strength, first of all, but it at least gives you something, a little bit more of a chance.
Troy, your 150 max pressure that you're reading off of the discharge part of the pump, depending on where that is, I'm not quite sure where that comes in, but if you were trying to supply a hand line off of one of your water outlets, and because of friction you want to run that at 170 psi
Okay.
for a fog nozzle, you're not going to be able to run a calves line unless, depending on where this pressure reading is, if you're running your pump at
Well,
170.
you'd be able to run a caps line, but it's going to be
So
it's going to be difficult, and it's going to be hard to hang on to. But yeah, if you're running the pump at 170, which means your air compressor is running at 150,
right,
you're not going to have a balance anymore
right.
at the end of your nozzle. But then that just begs me to question what the heck we spent all the money on the compressor system for if you're running a water line. I mean, I just don't know what would be your application for running 170 psi of water if you're trying to
Well, I mean, if you're looking at third and fourth, you know,
third and fourth lines.
Right, exactly. You get other people going in, or you're supplying a lot of stuff. I'm just trying to
Yeah,
play the what ifs.
sure. That's a good question. That would be your limiting point. I mean, at that point, you don't have equal air pressure to water pressure anymore.
Right.
And you can still pump air at 150 psi into a water stream at 170 psi. You've just got to give it a lot more volume to try to overcome that pressure differential. But if you leave space in the hose, it should still be able to push past that check valve, even though it's got 170 psi coming this way. Because it's caps, because it's a compressible medium, you should be able to force air into there, even at a lower pressure than what the water and foam is at.
Okay,
But-
now backtrack up, because I think I lost, you know, on your, let's say on your cap, you're running 170 in your pump.
Okay.
What I'm trying to figure out is, you're basically at 150, you've got a manual shutdown. Did I not understand that correctly?
Oh no, that compressor's not going to shut down. It's just not going to build any more pressure.
Oh, okay, so
It's
it's
just
gonna
going to
hit
sit
the
at 150 psi and sit
So
there.
if you gate down your discharge line for your cabs, you still can.
Probably force air in past that, but it's going to be a
Right.
pretty high velocity line of caps coming through there. But you also have to keep in mind there's a point where you're going to spin your pump at such a speed, such an RPM, that you're going to be overspeeding the compressor. And if it really comes to that, I mean, I think we have an overspeed light on the system, but I'm not sure where it comes in. Probably at about 200 psi, but if you're really running that kind of pressure because of your length of line, I mean, what type of nozzle pressure do you need to run?
Well,
If you're having to run
if you're talking about
That's
one
a finish and a half.
no, inch and a half with a fog nozzle. You're looking at 200 feet. You're looking at 170 psi because you get 35 psi for 100 feet of line. And just water. So it
Okay.
won't take much.
Okay.
Inch
I
and a
have to be
half.
honest, I haven't done that type of water pumping in a long time. I mean,
Okay.
I've been focused on caps for such a long time that I haven't, I mean, I thought it was like 7 psi per 100 feet friction loss drop.
Maybe if you have
regardless.
class A foam or something,
I
but.
don't know, I'm not sure. I gotta claim ignorance on that one, I don't
Okay.
know what to recommend there. I haven't ran into that scenario where people have said they've had to pump at such a high pressure in addition to running calves. But, I guess if that opportunity arises, we'll just have to figure out the best way to think about it. Let me give that some thought and I'll see what I can come up with.
Well, when you give it some thought, let me know, because that kind of leads into one of my other questions later for pressure, pump pressures.
Okay. Okay.
When you're ready.
Sure. The only other component on here that I just want to mention, there's a sensitivity valve adjustment it's both the blowdown port and also this control air bleed off port. There's a little sintered metal filter and a little valve. That valve is not meant to be wide open or fully closed. The position that it's set at in their factory should be left right there. It's about 3.5 to 4 turns open once it's fully closed, and that needs to be set at just that point. If it's closed down completely, your compressor system won't auto balance correctly at all. And if it's opened up much more, it'll start causing your compressor system to not notice the water pump pressure 4 times a second. It might only look once every 4 or 5 seconds if it's too far open. And what that'll do is that'll allow that water pump to tell the air compressor to do things, and it won't look back often enough, and you might start blowing your 200 PSI safety relief valve because it keeps this inlet valve open too long. Okay, so there's a little valve inside that pump compartment. If anybody's already spotted it, just be it known that you don't want to mess with that. Just leave it right where it's at. We used to put that valve and this manual pressure control adjustment valve on the pump panel. You'd have a manual pressure adjust and a manual automatic valve on the pump panel that you could tinker with, and they were always getting tinkered with. And I was always getting called, our compressor system's blowing the poppet valve, or our compressor system won't build any air pressure. And it was almost 99% of the time that somebody was tinkering with those settings.
Oh, show it to us.
Yeah, I think I'll keep that hidden for right now. That's why we kind of keep that buried back inside the pump compartment so that it's not supposed to be adjusted.
That which can be turned will.
I've even contemplated taking that little valve and cutting the knob right off it, but as soon as you do that, then I'll need to make an adjustment on it, and I won't have a vice grip in my pocket, that kind of stuff. But I think that should pretty much cover how the plumbing works for both the pump side and also the compressor side. We already touched on the air filter, the oil filter, and the separator cartridges, as well as the oil. Those are basically the 4 things that need regular service intervals. There's no other components in the system that need any maintenance. The strainer's self-cleaning.
Could you run over those 4 components again?
The air filter, the oil filter, the oil itself, and the separator cartridges, the separator filters. And just so that you can see what I'm referring to, I'll show you that.
I'll show you where all those are on the truck.
Okay, that's what I need.
Just want to show you in the manual. On one of the pages in the manual, you'll see there's a compressor maintenance page and a breakdown in time or hours when how often to change those 4 different things. And then what there is on the bottom here, it'll talk about the type of oil. It gives you the weight and a couple of cross references, part numbers for the filters.
Are we supposed to have this manual?
Yep, you'll have 2 of them.
Oh, you're bringing.
They should already be here, and we packed them up and sent them with the truck. There'll be an oil, this describes the oil change, describing those separator cartridges. There's actually 2 of them in here. How to change the oil in the oil filter, the air filter, and then, but that testing the safety valve, I leave those alone. Those things are like pressure valves on water heaters. As soon as you tinker with them, test them to see if they'll go off, they never seal again. Gotcha. The only difference is yours will say LDM PC.
I don't remember seeing that.
I don't remember seeing it either.
Really?
No, I
And
didn't
that
either.
box, that cardboard box of manuals I want?
Yeah, it's
It's right there. It's inside that manual right there, the one that you have in your hand.
This one?
Okay.
Yep. The only difference is Steve Schultz, our engineer, will take this binding off
Okay.
and he'll 3-hole punch it and put it in that binding. Should be right after that Foam Pro section, I believe. Yep, now you're getting into it. Those are the one under your hand. No, you're going the right way. Keep going through it.
Okay, wait a minute.
It's still going.
You're about 10 or 15 pages away from where the pump manual starts. Now that's talking about the clutch, which, there's your pump breakdown. That's some of your first few pages right there.
Okay,
And if you go back in about 3 chapters full, you'll run into the pages that talk about the maintenance for the compressor itself.
okay.
So this will be, all our engineer does is he'll take this whole thing, we put these nice manuals together in our pump division. He turns on, takes this apart, takes the nice clear covers off, throws it in the garbage, 3-hole punches it, puts it all in that manual. I don't know why
Well, I
we just
knew
don't
this
send these
manual
along
was
with it.
critical, but I haven't
Yeah.
memorized it.
Come on,
Get
John.
to it, John.
And you'll find there'll be a troubleshooting guide in there for the compressor system. All the same schematics that I have here up on the board will be in there, as well as that, that maintenance section describing where the air filters are, how they're changed, that type of thing.
There's no
Yeah.
air control.
Air.
This one's a little bit different. I leave this one here with you, so if you had an extra one to hang on to. This one actually is our midship, it's not a PTO drive.
The air filter check is 25 hours unless you're in adverse conditions like dusty environment.
Okay.
So that would be like twice a day under 20s.
Okay.
If you're
So
running
that
pump
might be
full
something
time.
we wanna have with us.
I already put it on my list.
Yeah. The air around here often has quartz in it.
Or a lot of ash.
Yeah.
Well, on windy
Especially if we
days,
go
get
on
a lot
these
of
big,
dust.
we go out on big federal wildland fires. And the, you know, the conditions there, I mean, dirt roads, lots of trucks, lots of smoke, lots of dust.
My sinuses still haven't gotten over
I
it.
mean, yeah, I mean, it's
Yeah, sure.
incredible the amount of particles in the air.
Well, at least you come with large intakes.
It's infected, still infected.
Any other questions? Operation, maintenance, the whole, you know,
If we're drafting from a pond or one of the lakes up here or something like that, is there any abrasion consideration? You mentioned the mixing chamber with all the veins.
Mhm.
Is there any abrasion factor involved in it?
You mean sort of from like the stuff that's in the water itself?
Yeah, pebbles, grit, you know.
Shouldn't cause too much of a problem. Anything that can get
Are
through
they
our
stainless
strainer.
steel or what?
Yeah, those are stainless steel discs and they're welded in. There's really nothing, I mean, the ports, the strainer port that cleans the water going to the heat exchanger has small enough ports where it's gonna filter out anything that could possibly plug the heat exchanger. Downstream, once the water's in, that clean water that's made it through your suction inlet strainers, there's nothing, nowhere that it can get lodged in here anywhere until it were to get to your nozzle. If you happen to have a fog nozzle on, that's gonna be your smallest path, your least resistance on the way through. So there's really nothing that's gonna cause failure for pumping sand or small pebbles or, I mean, it's gonna, you might hear them tinging off the bronze impeller as they're going through the system, but we haven't run into any pluggage problems whatsoever.
You mentioned a sensitivity valve. Do we need a therapist to deal with this?
Well, I'm sure I do after all the tinkering that people have done to that thing over the past 6 years. There were quite a few times where,
You haven't been to the sensitivity training?
yeah.
It's required.
That 4 times second sampling, is that the mechanical control of it?
Basically it is. It's, that diaphragm valve has the ability to open and close that thing 4 times a second is what it comes down to. If there are that many changes, it can open and close itself fully 4 times a second. And the only time that will pertain is if you're flowing slightly less than the maximum volume of air, which means that air inlet valve has to be nearly all the way open, but then there's either nozzles being open and closed or just the distance in pressure drop across the length of the lines that we have, it could open and close a maximum of 4 times a second. Otherwise, it's taking place actually quicker, that's taking place on a continuous basis. It's not only doing it 4 times a second, it's doing it continuously. But it could open and close these valves up to a maximum of 4 times a second. Okay? Any other questions about operation?
You say you could adjust the pneumatic pressure. Where is that adjustment? Is that just for?
It's near that sensitivity valve.
Yeah, is that just for the quick disconnect lines?
No, the quick disconnect line is actually a secondary regulator that should be
That's
very
what I'm
near.
asking.
Yeah, that should be very near one of your side panel, those door openings. We can point that out, we'll go around the truck and we'll point out all the different components so that you can see inside the pump compartment what these different components are. We've just kind of talked about in miniature scale on the board.
Factory would set that at what?
At the factory, I think I got them set at 90,
Yeah.
because almost every air tool that I see come out with a warning sticker says 90. Some of them say 95 or 100, but I think we set those right at 90. Somewhere between 90 and 100 should be where it's set. And that's PSI.
I don't think it'd be nanometer stuff.
No. I tell you, it's handy to have that air compressor on board for, you don't think about it as often, but there's times where you'll be in a situation where it might be a matter of somebody pulls out the spare tire on the road and the spare tire is flat,
Yeah.
and you're driving by and you can quickly pull out an air hose and pump somebody's tire up and not, go home the hero. But, I mean, spare tire, pumping up that type of thing, or using it to blow debris off the road in an accident scene, that takes a heck of a lot less time than it does to go pull a brush out of a compartment and carry a broom around every time you want to. I don't know, you guys probably don't respond to a whole lot of car accidents, or maybe you do. Maybe I'm completely,
It's relative.
That's right.
Deer collisions.
Yeah.
Relative to the number of calls we run, it's in direct proportion to everyone else.
Sure.
Yeah.
Deer collisions, I don't know if enough compressed air to actually blast the deer off the road. Might still have to grab an ankle
There's
and
some pretty
drag.
big ones, right?
They usually get up and go on their own.
Yeah.
It's the
Yeah.
car that's dead.
Exactly.
Are we at a good stopping place for a little bite to eat?
Sure, yeah.
I mean, are you done with?
Yeah,
Is
this
the
is,
classroom part?
this is pretty much it for classroom. I mean, unless we want to start getting into how foam works and what foam does and all that kind of stuff, which I just feel, I mean, you guys have already been using foam, you're more knowledgeable with foam usage than 99% of the rest of the fire departments in America, so I don't want to bother you with going through how foam works and, how bubbles are made and that type of thing, but this is pretty much the classroom presentation. Describe what's taking place inside the pump and then go out to the truck and try to describe where everything's located, how everything's operated. We've already touched on the fact that the compressor should be shifted before the pump. If you want to get the compressor in gear, you need to shift it prior to shifting the pump in gear. From that point,
Will the interlock keep you from disengaging it while?
now that's the nice thing, you can actually disengage the air compressor anytime you want.
Okay. It
You
will,
can take
it
it
will
out of gear.
disengage smooth.
Yep, it'll pull itself out. I don't recommend it on a regular basis. When you go back in the cab, shut the PTO for the pump off first, if you're gonna then shift the compressor out of gear, because all you're doing is you've got gear surfaces that, let's say they've got 2 inches of drive surface meshing. As they're pulled apart, they're under load. It's spinning, the whole gear is spinning. They're under load. As they get to that last little tidbit of drive that might slip across each other, and you'll start to create an additional taper to our already tapered gears, and it's just not required, but it's it's desirable in an emergency application. If you've got an air hose or an oil line inside the compressor system that were to burst during a fire, you want to be able to take that air compressor out of gear without shutting your fire pump down and leaving your firefighters at risk of not having any water pressure inside a structure. So you can take that air compressor out of gear at any time. That was one thing that we had to make sure we built into any of our CAF systems is disengagement at any time. Re-engagement only if the pump PTO is not engaged prior.
I
Okay.
think you touched on the main thing though about just the proportioning and the bubbles,
Yeah.
bubble structure, as far as
Right.
different types of bubble for attack and structure protection.
Yeah, and one other thing I'll mention that is if you have a deep-seated fire, let's say you have peat moss or bog or a bunch of piles of pine needles that are burning down inside, you don't necessarily want to go up to that thing with caps and be flowing a nice layer of bubbles on top of that thick debris surface, you might want to leave your compressed air turned off and turn your foam proportioner from 0.3 even down to 0.1. Because one thing that's scientifically known about Class A foam is that it makes the water as wet as it possibly can be for soaking in and penetrating at the lowest percentages that we can meter it at, 0.1% or 0.2%. As you start to go up to 0.3 or 0.4%, the water actually gets stickier than what it is at 0.1 or 0.2%. It's still better than plain water at, with no foam whatsoever, but plain water, typical tap water from coast to coast, roughly runs in the relative number of about 98 dynes per square centimeter. And that 98 dynes per square centimeter applies to how much water wants to bond to itself and form droplets. If you spill water onto a table or onto a countertop, it's going to want to, it spreads out to some degree, but it wants to try to form droplets and bond to itself. By adding a surfactant or a surface active agent like foam or soap, it allows that water to spread out, thin out, and soak into things much more readily. And that 98 dynes per square centimeter of plain water gets dropped down to about 40 to 45 dynes per square centimeter, or cut in half if we just add 0.1% of Class A foam. As you go up, you don't see that dynes per square centimeter drop at all. So the smallest percentage we can set it at for these deep-seated fires, down to 0.1 or 0.2%, is going to give you a much better soaking liquid than if you try to go with more and more foam concentrate. And if you can avoid any aeration, it'll just slither through and soak into that material and hopefully penetrate down into the heat and start to smother out the fire. But that's just one of the little tidbit of information. I see a lot of people go to a fire and they think the shaving cream type of foam, that really dry foam, is the best foam to use for anything, because that's what they always practice with their demos or their training. They always make this fluffy shaving cream, and they can't figure out why, as they're shooting it into the fire, the heat just lifts their bubbles up in the air and takes it away, and they don't get anywhere with it. So they need to learn to open the water volume up more and use the propulsion from the air to get it into the fire. But when it comes to actually trying to soak it, I've seen them cover dumpsters. They'll come up to a dumpster fire and just cover it with shaving cream foam, thinking they're going to cut that entire dumpster off from oxygen, and then go home and realize that all that oxygen that's under all that foam continues to burn and smother, and the dumpster fire burns on all night anyway underneath that nice blanket of foam. So you need to figure out what type of fire you're trying to fight and how you're going to do it before you just turn on your compressor and start making a bunch of big bubbles. Calves can make great bubbles, better than any other form of bubble making known today, but that's not always what you want for fighting every type of fire. Okay? Any other questions?
I think I've got the one of the pump pressures.
Okay.
What do you recommend with your calves? Because I'm finding quite a few of the local departments are going back to their old pump pressures.
Okay. Those old pump pressures are?
Well, based on your friction loss without foam and without air.
Okay.
So they're generally like on a 3/4 inch head line, 200 feet, that's 150 PSI.
Okay.
And then they add their air and they add their foam and they just leave it at that. But they're also running fog nozzles on them. But,
Okay.
so
I recommend for all firefighting with a calf system across the board at 125. The only time I say you can go in with less than 125 PSI is if you're just fighting a small room and contents fire with one of your hose lines and you don't want to redecorate the room with the energy that's known with compressed air foam. You can go with a lot less pressure than that. Because calves, you guys know, you don't really have any friction loss with compressed air foam.
And we also have nozzles that can go, we got your new combination of them, they can go smooth bore, and they can go to, fog and straight.
Right.
So the resistance on that changes from 80 PSI for a smooth bore, if you're doing straight water, to 100 on a fog. And I was just curious, so you're just saying 125 across the board
For calves.
for calves?
And for water, I'm going to tell you to do whatever you want to do, whatever you've done in the past.
Right.
And if it affects the way we run the calves, then we'll have to come up with calves tactics at those pressures.
See, like 125, I would think would still be high for a hand line with a smooth bore.
with calves.
Yeah,
It is, it's a lot of nozzle reaction.
right.
But as you work through a structure, you don't have to worry about your hose line kinking behind you. That's why I recommend 125. Because with that smoothbore nozzle wide open,
Mhm.
as you're rolling through the structure, if you've only got 80, 90 PSI hose line pressure, you're walking through the thing and every doorway you walk through kinks off your line and you gotta shake the hose, you've gotta pull it through a little bit more. So at 125, I don't have any issues with hose lines kinking with smoothbore nozzles on the end of the line for advancing into structures.
No.
But it is a lot of energy when you
Right.
open that, especially after you shut the nozzle
Like,
down and reopen.
like in a 2.5, you have somebody pulling a 2.5,
Oof.
you'd launch them.
Yeah.
Okay,
I don't get into a whole lot of 2.5-inch interior firefighting,
right.
just because it's such a large nozzle to have
Such
to
a
drag
big
around.
music, right.
But 125 PSI is still the pressure that I recommend
And
for
for
firefighting,
master
even with
stream
that
as
2.5.
well.
Yeah.
Okay,
I mean, you can work at less pressures than that, but I would only do that with smaller, very easily controlled room and contents fire, open car fire, something where you can see all the scenarios around you.
mhm,
But as far as having to run higher pressures as a result of having to run plain water lines in addition to calves, I hate to do that, but I'd hate to say, I don't know who you're talking about for as far as neighboring departments with this, but, bounce some questions off of them, and I'd like to hear how they're reacting to running with calves. I mean, you could turn on the foam and still get foam, and all your hydraulics still basically pertain exactly the same as if you're running plain water. But where the kicker comes in is trying to get the compressed air in there without adding so much nozzle reaction.
right. I've had the conversation with a few different departments, if you wanna know, and actually, Sugarloaf, they just basically kept all their training of pressures for water and said, this is what we're doing.
Okay,
And they just almost fell over when I asked them why.
sure.
They didn't, why would you ask?
Yeah,
Well, you don't have friction loss.
yeah.
Woo. But Boulder Roll, for example, they've went down to real low pressures and now they've brought it back up to pressures partially, back up to the water pressures partially for simplicity of engineers.
Uh-huh.
So you can run hand lines with water and run calf lines.
Sure.
So I was just curious of what we're preaching.
Well, I just pretty much say 125 is my operating pressure.
Uh-huh.
And you can go less than that if you feel you have a pretty easily
Well,
controlled
there's times where
service.
we want to, like if we're pumping to a wildland supply line,
Oh, yeah, then it's totally different. If you're not firefighting, then we're talking completely different.
firefighting.
I mean, if you if you don't have fire at the end of your nozzle,
I'm just picking on you.
if you're relay pumping, then it's a different deal. You're gonna wanna give them whatever they tell you they want.
Well, yeah, if we have a
Is that
big, long hose lay of 2.5 for some reason, we might, there's no way we're gonna flow calves off that truck, but we won't need to.
Why not? Pump them calves, tell them to shut their engine off, feed it into their manifold, and use their nozzles and their.
Well, then we won't be pumping at high pressures either.
You won't, yeah, that's true.
Okay,
That's the other thing that a lot of guys do with that 2.5-inch rear discharge, is you'll hook up a 2.5-inch feed line, you get to a neighboring department who's already on scene,
Mhm.
and they've run out of water. If they don't have calves, you could feed your calves right into their main discharge head manifold, pump it right into their 2.5-inch.
you won't disconnect you just pump it into their,
Tell them to shut their tank off, shut their engine off, and just pump right into one of their main 2.5-inch discharges. Put a double female on there,
right?
and just hook right into their pump, and feed all of their hoses that are already deployed. All you're doing is you're pumping your foam bubbles, your caps right into
They
their
still
manifold.
need their impeller to run.
Nope,
No,
you're
he's saying
above
going into the outlet
it.
side.
Going into the
Going there.
discharge.
Oh, into the discharge
Not
size,
into the
okay,
suction
into one
side.
of the discharge sizes.
Yep, right into
That's
their
a good
manifold.
trick.
Their discharge tank
Okay.
becomes your plenum.
Right, now, yeah, you're just using their manifold. All right.
All their hoses are already pulled, they're already pointed at the fire. Pump calves right into their pump manifold and let them experience calves shoot out their nozzles.
Oh.
Their nozzles might not be as fine tuned
That's
for
exactly
calves as
what I was
yours
gonna say.
are.
They probably have fog nozzles going.
They probably will, but it'll
But they'll
still,
still get some Class A foam and some air and.
it'll strip out a lot of the bubbles, but it'll still come out the ends.
Right.
And he'll do a good job beating the friction losses on the supply line.
Yeah. Or you can just pump them foam and water too, but that same
Trick.
thing applies.
Cool.
Sometimes you'll raise eyebrows, sometimes
I'll
you'll
bet. No, I bet you get
get
some
your
big,
fists flying, but.
get some big eyebrows looking up to the.
No, we want to go in the outlet.
Yeah, just trust me. Okay.
It'll be good for your pump.
People out here though are much more open-minded to that type of thing than if you try doing it in New York State or you know.
Well, it's not to be
Parts of it.
open-minded, but I have to admit, if I was sitting there as an engineer going, what, you wrong one, you idiot. This would be my first response.
You know.
So, but no, okay, that makes sense. I mean, not that I'm open-minded, but I just viewed it as a mistake.
I came here from another department where we did a lot of traffic accidents and structure things. So my experience is mostly in ladders and the hearse tool and things like that. This is the least experience I have.
Okay.
Suppose you have 4 people like me, wind up taking this engine to a fire. And most of what you talked about, as I understand it, is sort of tailor-made for the kind of fire you're dealing with. Would it be possible to say average everything out and give people like me, whose strong point is not hydraulics, give them a list that says, if you don't know how to fine-tune the system for a particular fire, do this.
Yep.
And give them an average of everything, and they can set that and know they're not gonna do any harm. Is that
Exactly.
possible?
Yeah, very possible.
That's, okay, that's
Actually, we're pretty much set at that.
Yeah, that's pretty much.
Well, you guys know everything.
Well, he just gave us the pressure magic
Yeah,
number,
125.
which we can
Okay,
pre-program
but-
into the
but does
control
that-
panel.
Okay, but does that cover all the variables?
We have the, I know the list you're looking
You
at.
have?
Nothing
I
carried,
thought I
covers
brought a
all
copy
the
of it. I think I might have left it.
We have it,
Yeah, because what that tells you is that when you pull up on scene, there's like a 12 or 13 step-by-step checklist. You pull up on scene, you set your parking brake, you put the truck in neutral. You shift your compressor into gear, shift your pump into gear. At that point, we put it in drive, right?
if you have water.
If you have water in the pump, exactly. I agree with that. If you have the
I know, we
water in
don't
the
have
pump.
fire
Details.
hydrants here.
So this list already exists, I just haven't seen
Yes.
it yet.
Yep.
Okay.
So you
And
put
it's
it in
great.
drive, but I'm gonna go through it anyway, it'll still be a good refresher. So you put the truck in drive, you get out of the cab, walk back to the pump panel, you open your tank to pump, you get water supplied to the pump, you crack your tank refill, so you take water from the pump and just recirculate it back to the tank. Your next step is gonna be hit your preset. There's an auto-controlled governor system which controls your RPM on the engine. You hit your preset, that's gonna run your pump pressure up to 120, 125 PSI. And that's adjustable. But that's gonna take your pump pressure and your air compressor pressure right to where it needs to be. Now you pick whichever firefighting hose you're gonna pull off the truck. You pull that valve to a preset location on the pump panel. You push your red button for your foam pro. You flip your toggle switch for your air. And that one's done. That would be your, meal deal that kind of fits every application.
That's what I wanted to know.
Yep. So that, it's simply just, and the only
And
difference
how
is,
many times in the course of all this do you say, oh my God?
hopefully, none.
Depends on how many part steps you miss.
Only when you open the nozzle and it scares the fire up. That's pretty impressive.
Yeah.
I can't find it. I thought it was right here in the front.
It is in there.
And then on the bottom of that step-by-step list of 12, 13 steps, there's a chart. And that chart, based on the hose size, there's 3 recommended flow rates to run for both your air and your water. Okay? And then there's 4 or 5 other optional
Is that it?
charts for what you could run it at. Yep, that's the one. And occasionally what we'll have people do is we'll take that sheet of paper, they'll laminate it and they'll top rivet it right to the pump panel or
We have
throw a copy in the cab or something.
Some floating around.
One in the cab and one on the panel.
So that'll give you your step-by-step,
That's exactly what I was asking about, okay.
sure.
It could even be like right inside the cabinet there, so just get totally messed
So
up.
you can radio.
Yeah, something like that, something like that. I was thinking like on a street or something. Go everywhere.
I asked a question based on the
Really?
assumption that if you don't know what you're doing, you can do some damage, but
Yeah.
I put a marker on that page.
Okay.
Yep, that's a good one.
And that's what we'll go out and do. I mean, if that's what the plan is, we'll go out there and we'll put the pump in gear and we'll run it through the scenario a few times and show everybody how the pump goes into gear, what it sounds like. But first thing I think we'll go and actually point out all the components of
That's
the
a good
stuff.
idea. And like the trick you showed about letting the air off.
Oh, yeah.